Hello and welcome to my channel. I am Mensa Augustine. In this lesson, we're going to look at how to calculate the standard deviation of a set of numbers. Now let us look at the question that we have here. How do we find the standard deviation of the set of numbers 6, 4, 5, 3, 8, 9, 6? Now let's see how we do it. The standard deviation is simply the square root of the variance. So we have S equals square root of 1 on n times summation of x minus x bar all squared. Where x bar is summation of x over n. That is the simple mean. So let us calculate the simple mean. In fact, we have one other formula that we can use to solve for this. But in this video, I'm using this formula, and then I'll do the next one in other videos. So here we find 6 plus 4 plus 5 plus 3 plus 8 plus 9 plus 6, all divided by 7. And this simply gives us 41 divided by 7, which is approximately 5.857. Wow. That is very simple as that. So we take the mean to help us. Now, how do we form this table? In a very simple way. We have x minus the mean. So if I want to calculate for this value, I'll take 6 minus 5.857, and that will give us 0.143. If I want to calculate for this, I will take 4 minus 5.857, and that will give me this. Now, how do we calculate for this? We take this one and square it. That is 0.413 squared, or 0.413 times 0.413. That will give us this. Then this one, we take this one, minus 1.857 times minus 1.857 to give us this. Or we take minus 1.857 squared on the calculator to get this. If you are punching this on the calculator, remember to bring brackets. If you do minus 1.857 square like this on the calculator, you get the answer to be negative. So note that. Once we are done with our table, then we are good to go because we can sum these values together. So we sum these to get summation of x minus x bar squared. So we found x minus x bar all squared. So let us sum these together. And if we sum these, we are going to get 26.857143. That is the sum of all these numbers. Now, take note of this. Here, I approximated this to 3 decimal places. You can do it to 1 decimal place or 2 decimal places. Or you can run it to a whole number. The same thing. This one too, we can approximate it to 2 decimal places. And here too, we can approximate all these to 2 decimal places. But I preferred writing all the figures. That is why we see this there. Now, we take the standard deviation as S equals 1 on n, and n is 7, times the summation. That is what we have here. 26.857143, all under the square root in a very simple way. So if we point this on the calculator, we are going to get our standard deviation as 1.957. Sorry, 1.959 to 4 significant figures or to 3 decimal places.